Hi everyone, this is Brian Ehlert. I'm a technical product manager with the NGINX Controller team over at F5. And today we're going to talk about automating data planes in AWS using NGINX Controller. Now, what I mean by data planes is, for those of you that might not be familiar, NGINX Plus is the thing that NGINX Controller uses under the hood. And it is really built around the NGINX open source product, and there's a lot of enhancements that have been added to that to give it good scenarios for API management, FIPS compliance. There's options for web application firewalls that are available through Plus. We can also get into health checks, high availability, true clustering at the NGINX level when we use that as a load balancer within our environment, real-time monitoring, DNS service discovery for your backend workloads. So you can just configure a DNS name in there and those workloads can come and go linked to that DNS name as they please. But Controller is the product we're going to talk about that's going to be enabling things. And really what Controller is it's a centralized place to bring together your fleet of NGINX instances so we can manage those in a central place. While Controller might not be a great fit for when we're starting out with just one or two instances, by the time you get to the point where you're running quite a few instances or in production and you want some greater insights into your NGINX fleet, or you want to be able to centralize management and views and start to wrap some role-based access controls and even an API to allow your internal customers to act upon multiple instances in a very safe and controlled way, that's where Controller starts to really fit for you as an organization. Controller has an application-centric approach, and by that I mean we're built around the application and the business logic of the way you think of an application. We're not just about managing instances directly. We're actually talking about managing the application. So we start with the notion of a thing called an environment. And within an environment, there's a container called an application. And underneath applications, there's things called components, which are, you can think of it, the path behind a URI, for example, or it could be a full FQDN. And those actually get deployed to things that we call gateways. And gateways are what we call the ingress side, or how your end customer actually gets their traffic to you. So whether they be a mobile application, whether they be a web-based application, that's the front end that touches your gateway, where your SSL offloading happens and where your load balancing happens and whatnot to your back-end workloads. So those are the objects that we're bringing together. So one team with one app can have different groups or different teams of individuals that might be acting on different components within that application because they own those back ends. In the end, they're all affecting the configuration of a single NGINX instance. So where through Controller we build the safety around that, where they can independently modify those configurations of just their portion on the fly without having to touch the entire configuration file of NGINX. And we'll test that configuration before it's actually pushed out and take care of the actual rollout of that, link it to the certificates. So you could actually have somebody else within your organization manage those certificates and whatnot. But let's go ahead and take a slightly different view of what this might look like in production, specifically to our capabilities around interacting with AWS. So here we have an NGINX Controller instance. I've logged into this, and this is the first page that you get into when you start to look at the view. So how I'm going to begin is I want to start to integrate with that AWS API. So I need some sort of way to do that, right? I need some credentials. So the first thing that we're going to do is we're going to come over here and we're going to go to the platform section. Mind you, I'm logged in as an administrator, so not everybody can get access to these features. So I'm going to go down into platform. Here in Platform, now I'm going to move down into our Integrations section. And this is how we actually interface with external service providers, no matter who they might be. So I'm going to go ahead and create an integration, and I'm going to say it's for AWS, and I'm just going to call it our service account because that's the key that I'm getting from is our service account. I'm going to give it a friendly name so we can do that. I'm not going to bother with a description. I'm not going to bother with a tag, but I'm going to say this is an AWS integration. If we were using a private connection point to talk to the API, I could define that here in the endpoint URI, but we're going to use the public API, so I'm just going to leave that blank because we'll default to that. The credential type we're going to use is an AWS access key. So I'll grab my access key. I will grab my access key secret, and I will go ahead and submit and set those things up. So now I have a credential that other portions of the system can actually share in and use. All right, so that's the first piece. I have a way to talk to AWS. Now the next piece, I'm going to head over to another aspect of our model, and I'm going to head over to the infrastructure. And within the infrastructure, you can see I have one instance here already. Now what I call an instance is a data plane instance. This is a machine that's connected to NGINX Controller that's running NGINX Plus, and it has the NGINX Controller agent running alongside NGINX Plus. So we can modify the configuration of NGINX Plus, we can manage it, we can monitor it, we can do those things that we need to alongside of it, and it reports back to controller. So it's pushing metrics up to controller and watching for event logs and watching for access logs and errors and all those things for us. So streams all that data in for us. So the first thing that I need to do is I need to create a location. By default, there's this location that we call unspecified. So if you create instances and you don't purposely put them into a location, we just dump them here in unspecified. But now we want to integrate with AWS, so we want to build a purposeful location. And in this case, I'm going to build a location, and I'm going to say this is my AWS location, and this is actually the Ohio region. So I'm going to be real literal, and I'm going to say it's US East 2, and I'm going to make sure I type that correctly. And the location type is an AWS location, which means something special to us. The integration object that I want to refer to, that integration account that we made, so that's my AWS account. The VPC ID, so this is the VPC that any machine that we deploy is going to attach to. So I want to pull forward the VPC that we use for this application in this region. I could make multiple locations, so you might think, well, why are you hard setting to just a single VPC? Well, we have 10 VPCs that we use in this region. Well, that's fine. You could create 10 locations, and that's just to make sure that we have a hard typing between the connection, because you're probably going to link those different VPCs to different instances and use them for different applications. So we want to make sure that we can support those models for you. The region, US East 2, and this is for the deployment information. I'm not going to bother with the description. I'm not going to bother with tags. If you were automating a creation like this, or you wanted to go through and define this as infrastructure as code, and you wanted to put these things within your source repository, you can start to save out these JSON snippets that we have here through the GUI. So you can discover through the GUI, and then you can take it. It would be a post command. This is the endpoint that you need to post that against, and you can recreate these objects at will based on that. All right, so now I've created the location. Now it's going to drive me straight into defining an instance template. So the instance template is how we know what type of machine you actually want in the end. And like I say, we're driving instances here, and we're actually going to create these on demand as they're called for. So we're going to go ahead and add our instance template. And I'm going to say this is for my demo, and for this one I'm going to use the marketplace image. And this is going to be a medium machine. So you can start to think of templates as a way that you can start to sort out your source AMI, combine that with a machine size. This will make sense as we move through here. So this is a template. The machine image ID that I'm going to use is actually coming from here. It's a marketplace image for NGINX Plus. I'm just taking advantage of this for demo purposes. You can bring your own AMI. So if you have a corporate OS, you can install your corporate OS. You can pre-install NGINX Plus into that, and you can use that as a base for this deployment process as well. I'm going to go ahead and use this Ubuntu AMI that we're referencing here. And for US East 2, this resolves to this particular AMI image for the latest version. The instance type. So this is the size, of course. This particular AMI marketplace image is limited to certain instance sizes, so I need to make sure I'm within that parameter. But in this case, I want to say that it needs to attach to a specific subnet. So this particular template is going to attach to this particular public subnet in this region. And the security group that I also want associated with that machine is the security group that we use for our load balancers. So this has the correct public ports, this has the correct block rules in there. And the public key I'm going to use is my own public key, because I might need to access this instance for troubleshooting later on, because operationally, I still own this machine. Controller doesn't own this machine. If something happens, if it gets compromised, I actually still own this for my organization. So I need to be accountable for that and actually get into that instance. So we want to make sure you can define your keys so you can access these machines. And the public IP address, of course I want a public IP address in this case, because I'm going to use this for a demo purpose, and this is going to be function as a load balancer for my incoming application. So if you don't want to use a public IP address, you're not establishing an EIP. So you're going to have it behind some load balancer that you might have that you might have in front of that yet. We can support that as well. So that's in there. So we're going to go ahead and create this. At this point in time, I've got the integration, so I know how to talk to AWS. We've got the instance template, so we know what machine you want to do. We've got the location, so we know where that machine actually needs to end up and reside. So now we're going to come back over here to instances. Mind you, I'm doing this all here through the GUI so you can see the graphical representation, but if you were doing this all through our API, it would be a very, very similar process. So now imagine a different person now within the organization. So I'm not the administrator here, but I need to be able to stand up instances. But at the same time, the same team within my company that owns NGINX instances and owns NGINX Controller, they're the ones who are actually responsible for these machines. So instead of me having to open a ticket in order to get a new machine provisioned, I can actually do that through Controller now. Okay, so now we're going to go ahead and we're going to create a new instance. But one of your teams, they don't have access to AWS directly, and you've enabled this through Controller so they don't have to create a ticket in order to get a new instance, which means somebody else has to go set it up. And we can do that through Controller here, and they can adhere to this small set of actually template deployments that are baked here into Controller. So we're going to go ahead and create a new instance. We're going to add a new instance using a template. And I'm going to go ahead and call this Demo Instance 1, since this is my first instance in AWS East 2, so that location that we had created. I'm going to use the Demo Marketplace template that we had created. I'm going to go ahead and submit. So that's going to start standing up my instance in AWS. As we see here through the console, we're going to watch for this instance to start to deploy. So now we can see this instance starting to deploy over here in the console. It's still initializing, so we're going to wait. The controller is going to monitor this, but the other convenience that controller is going to do for you is controller is going to go ahead and it's going to inject the controller agent into this instance at deploy time for you. So you don't have to worry about pre-baking either the controller URL location or the controller agent version into your images. Controller takes care of that for you on the fly. All right, so now that instance has had a chance to deploy, the agent's installed. So if we come back over here to the controller interface, we can see this instance is now available here. It's in that location that we defined, and we know it's a managed instance, as in managed by controller, and it's connected. So what the convenience here that controller is giving you is controller is allowing you to segment the control over your deployment process of your machines. So now your developers no longer have to say, we need some additional capacity. Could you operations person do this? You operations person could say, well, you need to create a ticket over here, and oh, by the way, it's going to take 2 days for that to get deployed. We can put some controls around that, and you can give that capability over to your users, and you still have control over the machine sizes, the individual images they can use. In the future, you can think this tied to some other capabilities, such as automatically scaling out. I mean, there's some other ways that we'll be going with this in the future in regards to NGINX Controller, so that we have and can give you and your internal customers greater control over your deployments. Thank you.